So really, I just want to make data huge again. We're going to make data great again in this country, and we're going to use it to make smarter decisions about how we use the ocean, whether it's siting offshore wind, energy development, or routing ships around whale hotspots. So fresh off the dissertation, I'm sharing, I'm not going to talk about building density surface models of where the critters are on the left, but I'm going to focus on how we can come up with this interactive map and plot to site offshore wind. And noticeably absent in offshore wind energy production is the United States. So there's Block Island that's coming online, but basically we have a 7 to 10 year time lag in getting the environmental compliance going. And if we want to look at wildlife impacts, above the waterline you have birds that could collide with the turbine, and below the waterline you have episodic pre-operational activities like seismic airgun surveying and pile driving. So I'm going to look first at birds. In this case, the study area is the Mid-Atlantic, and the Google-backed initiative for the Atlantic Wind Connection is also here. And so, so it's population rich. And sorry, equation. This is a very unfriendly slides compared to past talks, but it's basically you got cost of the transmission and the wind speed, which gives you the revenue, and basically the further offshore you go, you get more value to offshore wind energy development, hence the turbine, and also a little bit further north you go. And then with the Atlantic Wind Connection, it cheapens the cost. So we take a bunch of bird data and we smush it together based on sensitivity to offshore wind energy, and we get a bird map. And the bird map is, this is cool to site some offshore wind, and that's a hot problem over there in the red. And if we take then those two maps, we can look at how much revenue we get to wind, and then how sensitive that same site is to birds. And we want that win-win scenario where it's like, okay, go on the upper right. Okay, so then we can look at what's the average utility of these things, map that out, and we get a few little places that are discrete and separate, and that's the average utility. So that's where to site based on long-term operational impacts to birds. And now let's look at when to do these like harmful activities like pile driving and seismic airgun surveying, so we minimize impact on the whales. So this is part of the table of the whales, and there's some Latin names, just so you guys get really confident that these are actually critters. And then we've got a conservation score that says, like, here's how endangered they are. And so the North Atlantic right whale is critically endangered. It's a migratory species, and we can look now not just for over space, but also over time, and get these different levels of sensitivity over time, month by month. So then we can look at those individual sites. So each color is a different site, and then cetacean sensitivities on the y-axis. So we want to operate and do potentially harmful things at the minimum. So when cetaceans are least present. And then you can wrap it all up into a nice interactive app that allows you to look at the interactive trade-off. You select sites there, they get highlighted on the map, you click on a pixel, and then you get to see what's happening over time. And so that's siting offshore wind. So real quick, now we're going to talk about how to do a different spatial problem, which is how you route ships around whale hotspots. And that's not British Columbia, but this is. And so there's this, this is not so funny because they were going to put in a big oil pipeline here. That's not happening anymore, but for the sake of argument, not yet. So they were routing some ships to get to that Port Kitimat, and we need to do this stuff in a systematic, prescriptive, data-driven, making data huge way. So again, we just like take conservation scores of critters, combine them, we get a hotspot map, and then this is different routes to go to Port Kitimat from the southern entrance, and this is like the Goldilocks spot route right there. And I encourage you to get in touch. Brand new company, brand new website. It's pretty tentative right now. But yeah, Ben at ecoquants.com. And thank you so much for your attention.
Very good.